Hello, this is KG Tutorials. We are going to do linear algebra 2. But before we begin, we will take a quick review on the complex numbers. Now, complex number is a ordered pair of AB where AB is an element of real numbers. It's written as A plus BI and it can be denoted as C equals to A plus BI, where A and B are the element of real numbers. Now we have two main identities in complex numbers. The first one is that the square root of -1 is I. This negative square root of 1 was used to denote I by a Swiss mathematician Leonhard in 1777. And then by the first identity we can confirm that I squared is equals to -1 when you multiply that out to get out, to get rid of the square root. Now let's take an example. Evaluate 7 plus 3i in bracket 5 plus 11i in bracket. So right here we'll just do a usual algebra. So I will break the first bracket by the second bracket. Just take the first term of the first bracket, multiply by the second bracket, plus the second term of the first bracket, multiply by the second bracket, or you can use the usual FOIL method. And by foiling everything out, you should get 35 plus 77i plus 15i plus 33i squared. Then now, when we come back right here, you multiply everything out, you will get the same result as FOIL method. Now when you are here, do not get tempted to write this expression in descending order of I, because remember here our main goal is to write our answer in terms of A plus BI. Now when you multiply when you add the like terms here, we will get 35 plus 92i plus 33 into -1. -1 comes from where? From the identity I squared equals to -1. So that's why we'll change a I squared into -1. And now when you add everything up, you will get 2 plus 92i, which is in terms of A plus BI. Now, why do we say this? Because A would be 2 in this expression and B will be 92. Now, let's take the second example. We have 5 plus I in bracket plus 6 minus 2i in bracket. And now here we also use the usual algebra. We just take out the brackets. When we take out the brackets, we have 5 plus 6 plus I minus 2i. Then now this will just simplify to 11 minus I. Example 3, we take out the bracket first, and then now here they say represent this thing in terms of A plus BI. Alright, now note that we have negative sign between the two brackets. That means the second bracket, every sign in the second bracket will change. So we'll have 8 minus I minus 4 plus I. Now when we add the like terms, we'll be left by 4. Now we must represent our answer in terms of A plus BI. So here 4 will be A, and then what will be B, because we have no any other term after 4. That means B is 0. So we'll denote this as 4 plus 0I. Now let's take complex numbers of conjugate. Right, what is a conjugate? Now a key here is the difference of two squares. Think of the difference of two squares every time when you see the word conjugate. Now, if I have A plus B, what do I need to multiply A plus B to get to a difference of two squares, which will be in this case A squared minus B squared. Here I realize that I just need A minus B to get to A squared minus B squared. So now that means the conjugate of A plus B will be A minus B, and vice versa. The conjugate of A minus B will be A plus B. Now let's take an example. Now they said to me, evaluate negative 3 plus the square root of 2i. Now I cannot do anything when I'm here. Like this is the end. I cannot do anything. I cannot simplify this thing further. But with the knowledge of the conjugate, the complex conjugate of negative 3 plus the square root of 2i is negative 3 minus the square root of 2i. So now by the conjugate, I am able to evaluate this thing further. I will take the term that they have given me and I multiply it by the conjugate. Then now I FOIL everything out. Then I get 9 minus 2i squared. Alright? So now we know that I squared is negative 1. So this will just be 9 plus 2, which is 11. And then now when we denote it in terms of A plus BI, it will be 11 plus 0i. Now, example 5. When we look at example 5 is not possible. It's not possible because when we take a very close look into our denominator, we'll find that we have the square root of negative 4, and we cannot take the square root of negative 4. We cannot take the square root of a negative number. It's not possible. It will give us error if we just type that into a calculator. But in this case, it's possible. Why? Because we are dealing with imaginary numbers. We are dealing with the complex numbers, and in complex numbers deals with the imaginary numbers. Then now as you know, everything is possible in the imaginary world. Why do we say this is possible? When we take a quick review on our identities, we'll find that the square root of negative 4 will just be 2i. So now let's start to change that first. Now this is what we'll have. Now what should we do? Because we cannot factorize, we cannot simplify further. So every time when I'm stuck, I cannot factorize, I cannot simplify further, I'll just remember the conjugate. So now here I would advise you to take a conjugate of the denominator. But in this case, because we have a fraction, you just have to rationalize by the conjugate. So now the conjugate of 1 minus 2i will be 1 plus 2i. So rationalize with it. So now when we rationalize, we'll just have all that. And then now when we simplify further, we'll be left with 6 plus 14 plus 12i minus 7i over 1 plus 4. Then now we simplify further, then we get 20 plus 5i over 5. Then now we'll just split those two things, and then now we'll divide 20 by 5 and give us 4, and then we divide 5i by 5, it give us I. So now that is just the basics to our linear algebra. So now to familiarize ourselves with the complex numbers. Right, thank you for watching.